Okay, so 5-1 was on perpendicular bisectors, and the rewind question number 4 says, write an equation in point-slope form for the perpendicular bisector of the segment with these given endpoints. Somebody remind me what point-slope form is again?
y1 minus y equals m, and then x minus x. No, x minus x1.
Yeah, I don't really care if it's x1 or y1, wherever it is. Just know that this one right here is the spot where you should put in the coordinate that you find. Okay, so all we have are 2 coordinates of this line right here. So you could draw it and try to measure a perpendicular bisector, but we don't really need to do that because I know that if I know this line segment AB, what do I know about it given these 2 endpoints? What could I find? You can find the slope of that line. And if you find the slope of the line, you can find the slope of a line that's perpendicular to that. So the first thing you guys did was find the slope. What's the slope of this line? You end up doing what? 5 minus -3 over 0 minus 6, or the other way around. It doesn't matter. You'll get the same thing. What's 5 plus 3? And what's 0 minus 6? So -6. What does that reduce to? -4 over 3. So if the slope of AB is -4 over 3, what's the slope of your line in this perpendicular bisector? 3 over 4. What do you do there to get that? Flip and negate. All right? So now we just need to find a coordinate, but not any coordinate because it's a perpendicular bisector, which means it's the coordinate where? Right in the middle. It has to be right in the middle. So I need the midpoint of AB. And how do you find the midpoint? Yeah, you do x plus x, which would be 6 plus 0 over 2. And then you do y plus y over 2. Because again, finding the midpoint is like finding the average. You add together and divide by the number of numbers. And there's 2 numbers here, so we divide by 2. 6 plus 0 is? 6 divided by 2 is? -3 plus 5 is? 2. 2 divided by 2 is? All right, so then I just plug those in, and I get y minus 1 equals 3/4 x minus 3. There you go. And that's the formula for the perpendicular bisector. Okay? So I know that you guys, I think from what I heard from the sub, you guys got through the 2 practices, but not the exit ticket. Is that right? You got through the exit ticket? Okay, so, okay, good. Then I'm sure it's somewhere. All right? So if you guys have any questions about that, please come see me during office hours because I'm not going to go over it any more than what we did right here, right now. So if you have any questions left on how to find the perpendicular bisector from 2 given points, come see me in office hours. Okay, we are going to talk today about incenters and circumcenters of triangles. And I don't want to preface this. I want to preface this by saying it's a little bit vocabulary heavy, but the information that you'll need to find when you're using it is pretty intuitive. Maybe not necessarily easy, but it is very intuitive, okay? Tiara, can you put that away, please? All right, so a couple words that you need to know that I'm going to use for the rest of the class. The first word is concurrent, which means 3 or more lines intersect at one point. They are called concurrent lines. A point of concurrency is just the spot where they intersect. So these 3 lines are concurrent, and X would be the point of concurrency. And the last word that's up here is circumcenter of a triangle. And the circumcenter is the intersection point of 3 concurrent perpendicular bisectors of a triangle. So 3 concurrent perpendicular bisectors. That is a lot to digest. Okay. So first things first, what kind of triangle is this? It's an obtuse triangle, all right? If I want to draw a perpendicular bisector in a triangle, how many perpendicular bisectors do you think there are in a triangle? 3. Why? Because there's 3 sides. So every side has a perpendicular bisector. That perpendicular bisector, let's say this is AB and this is C. If I'm looking for the perpendicular bisector of AB, what would it have to go through? What point would it have to go through on AB? It can't go through A. It would have to go through somewhere on AB. Where? Right in the middle. Because it's the perpendicular bisector, which means it does what? Bisects it, so it crosses it right in the middle. Okay, I have a really bad perspective because I'm standing right at the board. Can you stop me when it looks like I'm in the middle? Right here? Okay. If it's perpendicular, that means it goes where? What does it do if something's perpendicular? Makes a right angle. So that means from here, a perpendicular line is going to go straight up and make a right angle with this bottom line. So the perpendicular bisector would look something like that. All right, what about the AC one? What would I do to find the perpendicular bisector of AC? Find the midpoint. Okay, again, stop me when I look like I'm in the middle. Okay, let's do BC while I'm right here. All right, BC would be about here? A little down? A little bit up? That one in the middle there? All right. Okay. All right, so the perpendicular bisector then of AC would have to be perpendicular to AC, which means that it makes what kind of angles again? Right angles. So I need a line that goes and makes right angles. Is this making a right angle? No. Okay, stop me when it looks like I've got right angles.
Go back up.
Like right there?
No, go up.
I think this looks semi-accurate, so we're going to leave it here. All right, and then this one right here, stop me when you think that I'm making right angles.
Wait, where am I supposed to? Oh, okay. Right there.
Here?
Right there. No, yeah, right there.
Right there? Okay. All right, so those are the perpendicular bisectors estimations. All right, now that I'm closer, I think this one might be a little bit down also. All right, however, I'm looking for a place where they do what? Where they meet. Where do you think they're going to meet? Where do you think they're going to meet? Are they going to meet inside the triangle? No, these are going to meet where? Probably outside. So if I extend this, and if I extend this, what do you notice happens? They're concurrent. What do you mean by that?
There's 3 lines.
There's 3 lines and they all intersect at the same spot. So the perpendicular bisectors of the 3 sides of a triangle will intersect at the same spot, and it's called the circumcenter. All right, this is called the circumcenter. That means this is a right angle, this is a right angle, and this is a right angle. All right, that's the perpendicular bisector of those segments. What? Where all the perpendicular bisectors meet, so where all the lines that make right angles, where they meet, is called the circumcenter. Now from here, from this point, from the circumcenter to every vertex is congruent. So from here to here, from here to here, and from here to here, C, let's call this D. CD is congruent to AD, is congruent to BD. So when you draw from the vertex to the circumcenter, those 3 are all congruent. You are not going to have to construct these. Okay, you won't have to construct these unless it's a right triangle. And the reason we'll do them with right triangles is because it's not that hard with a right triangle. Okay, you will need to know that the blue lines here would be congruent. Okay, so we'll take a look at a couple more practice problems. You also know, since these are perpendicular bisectors, what could you say about this line and this line? They're also the same. So those have to be the same. This one and this one have to be the same, and this one and this one must be the same. Okay. All right. So this right here is just telling you that, but I think this picture is really small, so I think it's a little bit challenging to see. But all of these, this triangle right here that we just looked at was what kind of triangle? Obtuse. So the circumcenter was where? Outside. If it is acute, where is the circumcenter? Inside. If it's right, where is it?
Right on the hypotenuse.
It's right on the hypotenuse. It's right on the hypotenuse, which is why it's easier to find the circumcenter of a right triangle because you know it's going to be on the hypotenuse. So whenever you guys have to find them, it will be a right triangle. And we'll talk about a shortcut way to do that. Okay? All right, so which line segments then can you say are congruent? If D is the circumcenter, which ones have to be congruent? AD is congruent to DC and also DB. So I got to draw that in there. And would also be congruent. Okay? Those are all congruent because from the circumcenter to each vertex is a congruent line. Okay? You also know that each part of this, like this one right here and this right here, these also have to be what? Congruent. And this one right here and this one right here are congruent. And we already know these two. Okay? All right, so those are congruent. All right, so let's use that. So this would be an example of where we use it. So KZ, LZ, and MZ are the perpendicular bisectors. So when I read that, I'm going to put in little right angle measures so I know which ones are the perpendicular bisectors. So KZ right here, LZ right here, and MZ right here are perpendicular bisectors. So that means Z is a what? Z is a... It's a concurrency. It's a point of concurrency, okay? And it's specifically a point of concurrency inside a triangle. So that makes it a, starts with a C, long word. Circumcenter. So Z is your circumcenter. So then which ones have to be congruent?
KZ and ZL.
Not KZ and ZL. Those are the actual perpendicular bisectors. HZ.
HK.
Nope. ZG. And ZJ, because those are the lines from the circumcenter out to the vertices. So those have to be congruent. And you also know that KH is congruent to which one? KG. And HL is congruent to which one? LJ. And then GM is congruent to MJ. All right, so the question says find HZ. So what would HZ be? HZ is congruent to which other ones? GZ and JZ. Do any of those have a measure on them? Yeah, which one? GZ is 19.9, so HZ must also be 19.9.
Also, you'll find the lines inside that are next to those. And
Yeah.
the ones on the outside.
Yes. The ones that are on the outside are congruent to each other. The ones that are inside, if they go from the circumcenter to the vertex, are congruent to each other. Okay, so find the circumcenter of RSO with vertices R, S, and O at negative 6, 0, 0, 4, and 0, 0. So where is negative 6, 0? On the negative side, so go left to negative 6, 0. And then where's 0, 4? Up 4. Okay. And then 0, 0 is the origin. Good. Okay, so this is what kind of triangle?
Right.
How do you know that?
Because
Because one of them is horizontal and one of them is vertical, so those make a right angle. Okay, so then if you were to tell me where you thought the circumcenter was, where do you think it is? Look back to your slides. On a right triangle, where is the circumcenter? Always on the hypotenuse? Just any old place on the hypotenuse? The midpoint of the hypotenuse. This is why it's easier to find a circumcenter on a right triangle because you know it has to be the midpoint of the hypotenuse. So if this is negative 6, 0, this is 0, 0, and this is 0, 4, how could I find the midpoint of the hypotenuse?
When you do the points,
Just find the midpoint. So how do we find the midpoint? Do what and then over 2? Add them up and over 2. So negative 6 plus what? And 0 plus over 2. What's negative 6 plus 0? Negative 6 divided by 2? Good. 0 plus 4? 4 divided by 2? 2. So what's my midpoint? Negative 3, 2. I can't draw perfectly, but that's where it would be. And so then this is the what?
This is the midpoint of the hypotenuse.
Which makes it the what of this triangle? Circumcenter. Because if I drew a perpendicular bisector here, a perpendicular bisector here, and a perpendicular bisector here, that's where they would meet, right there at the circumcenter. If I asked you to find the circumcenter of, say, this triangle, all right, first of all, that would be mean. But you could do it. You would just have to find what? You'd have to find the perpendicular bisector how many times? 3 times, and then you'd have to find a point where they all did what? They all met. Okay? So it's a bigger challenge on a random triangle than it is on a right triangle, because a right triangle is special. The midpoint of the hypotenuse will always be the circumcenter. Yes?
For the midpoint formula, if you have three plot points things, do you do all 3 or just do the
Oh, like, do you need to use this one too? No. Why not?
because it's not part of the
It's not part of the hypotenuse, exactly. So I don't use the origin here because it's not part of the hypotenuse.
also you just use it
I just use the 2 endpoints of the hypotenuse to find the middle. And then the middle, you assume that these would meet there because, again, the circumcenter of a right triangle is always, always, always the midpoint of the hypotenuse. Okay. All right. So at your boards, I want you to find the circumcenter of this triangle. Okay, can anybody explain or walk me through, is there an even shorter way to do this? Because if I plot this 0, 9, is that right?
no 8.
0, 8. So 8, 0, and then 0, 9. When I plot that, then I know that my circumcenter is going to be somewhere around here. All right, and it ends up being 8 plus 0 over 2 and 0 plus 9 over 2, which gives me 4, 4.5. And I know that that works because this is what kind of triangle? It's a right triangle. So it's going to be the perpendicular bisector is going to be on the midpoint of the hypotenuse. So Tiara, what would be a shortcut way of doing that? Just divide both of these numbers by 2. This is your y because it's in the y spot. This is your x because it's in the x spot. So just divide those 2 numbers by 2. All right? You will have 0 there. If you didn't have 0 there, it would be different. Don't worry about that, though. You will. Because they're always going to be centered at the origin for our purposes.
So there'll always be 0 there?
Yes. Mm-hmm. All right. Okay. So the circumcenter is the intersection point or the point of concurrency of the perpendicular bisectors. The incenter of a triangle is the intersection point of all the angle bisectors. What's an angle bisector? It bisects what? Bisects the angles. So say, for instance, we have this triangle. Let's say we have this triangle. All right, and I want to do an angle bisector. An angle bisector, if I put it here, oh, that is an uncomfortably thick line. That's too big. All right, let's pick a different one. Okay, if I want the angle bisector is going to do what to those 2 angles? It's going to cut the angles in half. So if I take the 3 angle bisectors of a triangle, they meet, and this point right here is called the incenter. All right, the incenter is the meeting of the 3 angle bisectors. So again, if it's an angle bisector, that means this angle and this angle are what? Congruent. And this one are, and what about this one and this one? Congruent. Okay, so the angle bisectors meet at the incenter. From the incenter to the sides of the triangle, everything is equidistant. So going back to the picture we just drew, from this incenter out to here, down to here, and over to this side, these dotted lines would all be congruent. Okay? So now it's kind of the opposite. Yep. So from the in-center outside, those lines are congruent. All right, and you also know that these angles are congruent. So if I told you this was 30 degrees, what's this one? 30 degrees also. If I told you this was 30 degrees, this is also 30. All right, which means these would both have to be 30 also because they add up to 6. They add up to 180.
120?
I think what Ivan meant was that these so far add up to 120, right? Yeah? Yes, Ivan, that's what you meant. Okay. All right, so these would have to also be 30 and 30 because it turns out that this looks like it might be an equilateral triangle. Okay. So let's use that. And again, this is pretty intuitive. All right? So I know it sounds complicated, but this is pretty intuitive. So take a look at this. It says find the distance from V to KL. So V is the in-center. And if I go from V to KL, this little dotted line would have to be the same as what? 7.3. Okay? Because that goes from the in-center to the other side. All right? If I put another one here, this would also be 7.3. All right? And then find the measure of VKL. So where is VKL? V.
V's right there. Oh, I see.
K.
L.
So it's this one right here?
Yes.
Okay, VKL is this one. Well, I have no idea what that is. How can I figure it out?
What is it?
Might not be 19. Jennifer?
So they tell you that angle L is 106.
This is 106.
Yeah, and then they give you the angle measure of 1/4.
Okay, so this is 19.
So you know the other side is 9.
Okay, so this must also be 19.
All right, so you add that all up.
All right, 106, 19, 19. What's 9 plus 9? 18 plus 6?
24.
24. 2 plus 1 plus 1? And 1. So that's 144. So that means what's left over for K? 136? 36. Okay, 36. So K must equal 36. And this little piece is what part of K? Half. So what would this have to be? 18.
I was close.
Yeah, you were close.
Mostly because I just let number there.
All right, so that one is 18. With these, I would say the biggest thing is to just make sure you know what angle they're asking you for.
So we got 77.3 because it's the same side.
Because this one to the side is 7.3, so then this to another side must also be 7.3. The 106 has nothing to do with the first problem, only the second.
Yeah, but what does it have to do with, like, I don't...
You need it because otherwise you couldn't figure out what these two were added together. You need it right here. That's the measure of this angle.
Oh, okay.
It's in degrees. Who said that? Okay, what part? Like the side or the angle one? The sides. So going back to the picture that we drew, this is the in-center right here, this in the center. If I go from here, if I'm standing in the in-center of a triangle, pretend you're in a triangular room. If you're in the in-center, to go to one wall is the same distance as it is to go to all the other walls. So then if we go here to this problem, the question says, how far is it from V to KL? Well, V is the in-center, so it's the same to go from this wall as it is to get to this wall. So if this one's 7.3, this one also has to be 7.3. Because if you're standing in the center of the triangle, to get from one wall to the other is the same distance. Kind of similar to like if you were standing in the middle of this room, if you decided to go over towards Mr. Vandrick's room or you decided to go over towards the stairwell, it would be the same distance. So let's go through one more time how we got 18 degrees, ladies. Okay, so all we knew was that this little angle was 19 and this big angle was 106. So if this little acute angle is 19, what does this one have to be? Also 19, because it tells you that they are what? Bisectors. So you know that if this is 19, This one has to be 19, which means together, what are those? 38. So J must equal 38 degrees. So imagine this triangle down here. All right, if this is 106 and this is 38, how would you find this one? Add them together and subtract from 180, which is what we did here, which gave us what? 36. Because 106 plus 38 gives you 144.
It's like if you're not looking
Because
at
it
the
says
line.
106. Okay, so then if this whole thing is 36, Kiara, how could you figure out a little piece of it? Divide by 2. And it has to divide by 2 because it is a what? A bisector. And bisect means cut in half.
So like the lines inside of it have nothing to do with
The lines inside of it have nothing to do with the angles, and the angles have nothing to do with the lines inside of it. So I would say the most mistakes people make on these problems is exactly what Daisy just asked. So using the lines to figure out the angles, don't do that. The angles are separate from the lines. Okay, go back really quickly here. The in-center of a triangle will always be where? Inside the triangle. It will always be inside the triangle. Unlike a circumcenter in an obtuse triangle will be where? Outside. On a right triangle will be where? Hypotenuse. And in an acute triangle it will be inside. Okay. All right, so QX and RX are angle bisectors of PQR. Find each measure. So I want to know the distance from X to PQ. So I want to go from X right here in this in-center to PQ. So how much would that have to be? 19.2. Why? You don't divide anything by 2 here. Because it tells you that XY is how long. So if that's 19.2, to get to this wall would also have to be 19.2. So this would be 19.2. And then last but not least, I want to find out PQX, which is PQX right here. So I know that I'm going to draw this separately because I think that makes it a little bit easier if we just get those lines out of there. I know that this one is 52. Do I know anything about angle R? Yes, Melanie, it must be. You were 24. Why? Half is 12, so the whole thing has to be 24. So then how could I figure out this whole angle up here?
Add them together, check 180.
Hang on. Go ahead.
they're asking for PQX, not PQR.
I understand. That's PQX right here. Okay?
Oh, I see what you're going.
All right. So we're going to have to find PQR to get PQX.
I'm telling you what you do.
Okay. Oh, all right. Go ahead.
You add them and check them from 180.
Okay, do it.
Okay. God,
All right, Tiara, what is that?
that is 76.
76. So it's 76, subtract from 180. 104. And then what are you going to have to do? Because this whole thing is 104. So then what would I have to do to figure out this one? Divided by 2, which would be, somebody just said it, 52. Thanks, Juan. 52.
Oh, so it's the same thing.
Same exact thing. So that's PQX. All right? PQX would be 52. Said he was tired of this and he just had to go. All right, do these at your board.